Hey everyone, welcome back to channel, and this is the day one of our Kubernetes series, and today we are going to discuss about why Kubernetes is required instead of Docker. Okay, so let's just begin with it. So here I have created one deck which we will follow in this particular video. So let's just start with the why Kubernetes and what is the problem with the containers. Okay, so the very first question which comes in the mind, if you're learning like Kubernetes and you have already learned about Docker and all, okay, so why containers are not enough? Like, is it enough or not? That is the very basic question. So basically what happens, like suppose you are building or working on any project, there you just build a application, you build a image, then you run it as a container. Then in that case everything works perfectly fine, right? Then why do you need Kubernetes? So there are some issues with the Kubernetes. For example, I just discuss with this use case of e-commerce. Okay, so basically suppose you need three containers. Okay, so at that time what you do, basically you will run your image three times using this docker run command -d, whatever your image name is there. So at the start, what is there? Everything is good, one container is good. Suppose growth of user happens, like previously this is the website and five like 100 users were there, your container is working fine. Suppose like after some time you started getting 1,000 requests per second, or some 5,000 or 10,000. Okay, and it goes on. Okay, so when growth happens, in that case obviously you need more containers. You can't just go and run again and again docker run command, right? And then yeah, the problem is you need multiple containers in that case. And if it crashes, so suppose your container is there, if it crashes, so in that case what will happen with those containers? You can't just go into the server and you can just do docker restart that container id, right? So that is a very like big issue here. So there are some five things which docker can't handle alone. So the very first thing is like container crashes, there is no self-healing. Like if container went down, so it can't automatically come up, right? Your service will be stopped at that moment. Then there is no traffic distribution, like load balancing is not there. Suppose I'm running three containers, so where traffic should go, that there is no here, no load balancer is there, right? Then you have a auto scaling. Auto scaling means like based on the load you can't manually add number of containers again and again and again. So there is basically manual scaling, right? There is no auto scaling. For example, suppose I am getting 1,000 requests per second, so add one more container or something, right? That thing is not here, so that's why auto scaling is also not there. Then you have zero downtime deployments and also multi-server management. If your container is running on the multiple servers, like for example 10 servers you have, and on each server some containers are running, which container is failing you don't know, right? So these are all the some of the things which docker can't handle. And also zero downtime deployment, which means like if you want to like deploy the new image of your service, then in that case the zero downtime is not possible. Obviously you need to make your container down, and you need to come up, right? And also load balancer is not there, so traffic, it's not like traffic can redirect to the working like old containers. Okay, so these are the five things which docker can't handle alone. So moving forward, like the very first problem we'll discuss is the container crashes, no self-healing. So here we have like if one of your three running containers goes down unexpectedly, so what docker does? Nothing, right? So docker won't auto restart it, and there is no monitoring, no alerting. So there is obviously manual fixes required. If you're working at such organization, then you need to manually log in into the server, then you need to go and check which container failed, and you need to manually restart it. So it's a very big issue. That's if it happens at night, 2 o'clock, 3 o'clock, how will you do? Then obviously, next point which you discussed about the traffic distribution. So users are coming, there is no load balancing. So how traffic will go to each containers? We can't decide. So Docker is not for this traffic distribution as well. So there is no built-in load balancer, no service discovery, no health routing, nothing is there, right? Then you have a scaling issue. We have, as we discussed, like Like if there is some Black Friday sale, like traffic spikes from 1000 to 10,000 1 lakh users in minutes. So there is before 3 containers were running and after unit 20, you can't just go and manually run docker run command, right? So that is also one issue with the scaling part. And next one we have is the more problems as you scale. So the problem we have about deployments, if new version is released, how we can update all the containers? Can you do it without downtime? No, we can't. And we, if any issue comes, then can we roll back? That is also a very difficult task here, right? Then next thing is multi-server. So if any container fails, then you need to find out on which server it is running. If one server fails, then how that container talk to across servers. So many things comes if it is like that. Okay, so now the main solution which we have is the Kubernetes. Okay, so we can tell Kubernetes we want some 5 copies of our app running or 10 copies or whatever we want. So in that case, what Kubernetes will do, it will automatically schedule containers, it will distribute traffic for us, it will restart also if any pod fails or any container fails. Then it will scale automatically based on the number of requests, and also the rolling update will happen like zero downtime deployment. Then also if any failure hop happens, then it can replace as well. Okay, so the Kubernetes focus is basically you focus on your application, Kubernetes manages the infrastructure. Okay, so this is the basically reason for Kubernetes, like why it is required. Okay, so this is the one analogy you have, like Docker is just like it. One car is basically like it creates and run containers, and like a car, it takes you from a place to B perfectly. But Kubernetes is basically like managing 5,000 taxi fleet. Like basically, suppose you are something and you have to manage some 5,000 taxis. So Kubernetes will be like it will assign drivers, routes, fixes, everything. So it is like that. Okay, so now let's see. Just this is a recap, and here we'll see what both the technologies solve. So basically, Docker solves for the packaging applications, running containers, consistent environments, and port binding and volumes are there. And in Kubernetes, so many things which we discussed just now. There is the auto scaling, self healing, load balancing, rolling update, orchestration, high availability. Okay, and yeah, it's not like if you're using Kubernetes, you don't need Docker. You need Docker obviously for the like images and to run it as a container. So but Kubernetes is just like managing those containers. Okay, so there's a one line summary at the end. We have like Docker creates containers and Kubernetes manages container in the production. Okay, so this is which now every company is using about like using Kubernetes. So next we will discuss about the Kubernetes architecture, and then later on we'll move on to the using one local cluster of Kubernetes, then running our workloads on that thing. Okay, so that's it for this particular video, guys. And if you have learned something new, you can just drop something in the comment. Yeah, so that's it, guys, for this video, and I will see you in the next one. Thank you so much for watching.